We are going to discuss work energy theorem for a variable force. As you know already about the work energy theorem, what is this? Change in kinetic energy is equals to work done. So here you already know the formula of kinetic energy, that is half mv square. Here we are differentiating with respect to t. So dk by dt, we have got here d dt of half mv square. Here we have just subtract the value of kinetic energy, that is half mv square. So we have to differentiate it with respect to t. Half m we will take it outside, and derivation with respect to t, what is this? 2v into dv upon dt. So we have got this half m, we have taken it is outside, 2v into dv upon dt. So 2 is getting cancelled. What is remaining? M into v into dv upon dt. So here we can write it m into dv upon dt into v. As you know already, the velocity upon time is nothing but acceleration. So instead of dv upon dt, we can take acceleration, that is nothing but a. So m into dv upon dt, it is nothing but what? M into a, and that we can put f according to Newton's second law of motion. M into a, it is nothing but f. So we can put it f into v. So we have got here dk by dt is equals to f into dx upon dt. So instead of v, we can put dx upon dt, because velocity it is nothing but what? Displacement upon time. If we will observe this equation carefully, dt is a present to the both sides, so we can cancel it. We will get it dk is equals to f into dx. Now integrating both the sides, see here dk is equals to f into dx. So f is force, dx is a displacement, and dk is what? Change in kinetic energy. So if we will integrate to the both side, the integration from ki to kf means from initial kinetic energy to the final kinetic energy, and here we will take initial displacement to the final displacement for f dx. So what is this? Xi to xf. So observe carefully, we have just taken integration to the both sides, ki to kf, integration from ki to kf dk is equals to integration from xi to xf f into dx. So here we can integrate this integration from ki to kf dk. What is the integration of it? Integration of dk is a k, upper minus lower. Upper is a kf, lower is a ki. So kf minus ki is equals to, we will write it as it is, integration from xi to xf f into dx. And you know that force into displacement, it is nothing but what? Work done. So instead of integration from xi to xf f dx, we can put it w. So what will get here? Kf minus ki is equals to w, and this is nothing but the work energy theorem for a variable force. Now let us try to understand about the potential energy. As you know already, there are two types of energy. The mechanical energy is divided into kinetic energy and potential energy. So what is a potential energy? The potential energy is the energy of body by virtue of its position. Now let us try to understand the different examples of potential energy. Here we have taken an hammer, and this is a block. So here we have taken a nail also. If you will observe it carefully, the hammer, it possesses which energy here? The potential energy. So here potential energy is getting converted into kinetic energy. If we will apply force, the potential energy is getting converted into kinetic energy. So observe it carefully. Here the work is done by hammer when its energy is released. So the potential energy, the raised hammer possesses potential energy. And what is the definition of potential energy? The potential energy is defined as the energy of body by virtue of its position. Now let us try to understand the formula of potential energy. Here we have taken a block whose mass is m, and the acceleration due to gravity, it is g. The height we have considered, it is h. So we have taken a body of mass m raised to the height small h above the surface of earth against the acceleration due to gravity, that is a small g. So the work done in lifting the body against the force of gravity is nothing but what? Force into displacement. As you know the formula of work is nothing but force into displacement. So what is a force here? Force is nothing but m into g here, and displacement is what? Here we have to take the distance here, the box, the body, it is moving from one place to the another place, and that distance is given here, and we have denoted that distance by the h. So w is equals to m into g into h, and this is nothing but the formula of potential energy. As you know already, the work done is stored in the body is in the form of potential energy. So the potential energy is nothing but stored work. So here we have got the formula of potential energy, that is mgh. If we will see the potential energy, it is which quantity? It is a scalar quantity. So this is about the potential energy. If you see the signs of it, here it is also be taken with proper positive or negative sign. Actually depends on whether the work is done against the force or by the force. So the formula of potential energy is what? mgh. Thank you.